Number one, I know 2 points. Because it's 2 points.
All right. Good start so far, but let's see what kind of level of success we have. Put your pencils down on your desk and pick up your colored pen. And you may even today draw a graph with your colored pen if you made a mistake, because unfortunately, if you made a mistake on numbers 1 or 2 or both of them, then your number 3 is going to be wrong. And we want your work to stay, and we want to see what the correct answer is at the same time. So if that comes up, we'll talk about it. All right? So everyone stay on your toes today. The equity bars will be used all day. Make sure you have an answer. Remember, there is no such thing as skipping something. No such thing. All right. We are on number 1 and number 1 only. Number 1, I have student number 12, 9, and 8. Student number 12, what did you put?
For one about y plus 6 equals negative 4 parentheses x subtract.
Okay, student number 9, what did you put?
I got y plus 6 equals negative 2 x.
So I think that was the same thing he said. I'm not sure. Student number 8, what did you put?
Y plus 6 equals negative 2 parentheses.
So it seems like everybody agrees there is actually another possibility because we have another point. Point-slope form can have many different forms, many different variations. But no matter what, the slope is the same no matter which point you use. So you'll notice that that's negative 2 no matter what. Unfortunately, if you have a plus sign where there's supposed to be a negative sign or a negative sign where there's supposed to be a plus sign, unfortunately it is wrong. We'll get to questions in a few minutes. Number 2. Number 2, what did you get? We got student number 6, 4, and 19. Student number 6, what did you put?
I put y equals negative 2x.
Okay, student number 4, what did you put? Student number 19, what did you put? Okay, so I'm not sure if that was the same thing. It's y equals negative 2x plus 5. So unfortunately, if you put minus 5, that does unfortunately make it incorrect. And the graphs. So unfortunately, if you got either of the first ones wrong, this is going to be wrong, but you can still learn from your mistakes. This is what the graph should look like. Yes.
I got both of the graphs right, but I messed up number 1 because I forgot to put negative 2 as m.
What did you put?
I put y plus 6 equals m and only x minus 3.
So how did you know how to graph it?
Because I used both of the points that it gave me.
And then you just, okay. So, all right. So unfortunately, number 1 is incorrect because you can't just put m. You have to put the actual slope. Okay. Now, if you have something wrong from numbers 1 and 2 and your graph is wrong, I want you to quickly take your colored pen and put in the correct graph that you have incorrect. It's very easy to do. You can, as Garion just pointed out, for number 1, you could just take the 2 points, plot them on the grid, and draw a line through them. For the second one, if you got the wrong equation, well, now you see the right one. It's easy. The y-intercept is 5. Put a point. down 2 over 1, put another point and draw a line through it. So we're talking about a 15-second to 30-second process. So go ahead and take care of that now. There is a reason. All right, so now we're going to talk about number 3 for a few minutes, and then I'm going to go back to number 1. I'm going to finish up with number 1. Let's start with number 3. These are both linear. They both have slope, but one of them has a special name. Which one has a special name? And what is the special name? Not going to go to the equity bars for this because there's going to be a lot of people who just don't know, but you should know. To be quite honest, every single person should know. One of these has something about it that's very different. Okay, Chopin? How do you know? Absolutely, you said that beautifully. This is a direct variation because it passes through the origin. We just spent the last lesson learning that. So that should have, unfortunately, that should have been instant. Instant recognition should be able to look at something and go, oh, well, that's not proportional and that is proportional. That's not a direct variation, that is a direct variation. Anyone have any questions about that? Okay. Something else happened in this. Something else happened. Any observations that you can make? There's something else going on in this graph. Put your hands down. You're going to have a 1-minute team talk, and I want you to talk about any observations you have and share them with your teammates to see if we can tease out a major thing going on here. You guys have an observation?
They have all on one question.
Okay.
I did all on one question.
How could you do that?
Be prepared to say something. Doesn't have to be necessarily what I'm looking for, just any observations that you can make. All right. What observations can you make? We'll start with Tristan, Paige, then we'll go to Garion and Amir. Tristan. Okay. Paige?
We said they have the same slope. They're both negative.
Oh, I like you said they're both negative and they're parallel. Okay, I lost my order. Garion?
Well, we came up with that it's parallel.
Okay. And Amir?
It's linear.
Okay. It's linear? Okay. Well, there's two different graphs, so when you say it's linear, you're saying, that's fine. Yeah, they're both linear, absolutely. Okay, so we had 3 groups who pointed out that they're parallel. So I have 2 lines drawn on my board over there. Are those 2 lines parallel?
Yes. Yes.
They are. They are.
Those are parallel, and these are parallel?
Yes.
Okay, let's stick with these up here. How could you prove it? How could you prove it? You got 1, 2, 3, 4, 5, 6 people who think that they can prove it. Okay, put your hands down. Now I want you to take a minute and I want you to come up with a way to prove it. Prove that they are parallel. It's up to them, not me. All right. So what'd you come up with? How could you prove it? How could you prove it? Alex, how could you prove it? The two lines never touched. Okay. What about here? On my board I drew these two lines. Will these two lines ever touch?
No.
Well, these are actually not parallel. I know that because I drew it myself and I angled one of the lines slightly differently than the other. They look like they're parallel, but they are not. So how do we know that these two blue lines don't just look parallel, but they actually are parallel? How can we prove it? Catalina. Do they have the same slope? Okay, so now this group actually observed this the first round of team talk. And you had said that you guys came up with the fact that they had the same slope. How could you, are you sure that they have the same slope? How? So I love the first thing you said. Look at the equations. Look right here and look right here. They have the same slope. Absolutely. Catalina, Paige, and their respective groups, absolutely. Paige also went on to say you could also just look here and do rise over run. Pick 2 points and do rise over run. Up 2 to the left 1, and then go here and here, up 2 to the left 1. No matter what, you get the same slope. And so what you just figured out was part of today's lesson, actually. What is today's lesson? Today's lesson is, oh, look at that. Parallel and perpendicular lines. And so now, could someone put this all into a statement? Catalina kind of did it already. Someone put what we just discovered into a statement. Make a statement that we can now use for the rest of our lives. Garion?
If two lines have the same slope, then they are parallel.
That was a perfect statement. I couldn't have said it any better. If two lines have the same slope, then they are parallel. In fact, he did that so well. Let me show you today's notes. It is almost as if Garion was there while I was writing up the notes. Amazing. Amazing job. So now, very good. So, does anyone have any questions on what we came up with? Tristan. How we got the line on the left? Well, that has to do with knowing how to graph point-slope form. So that was something that we learned in a previous lesson. Could someone, let's use this equation. Let's use this one right here. Can someone tell us the starting point? And this is where Amir wants to pay extra close attention as do the other students who tend to be towards the back. Could someone tell us the starting point for the one I circled in green? What's the starting point? Amari?
6 and negative
Unfortunately, that is not the starting point. That is not the starting point.
-3 and 6?
Well, you're closer, but that is still not the starting point. Cheyenne?
3 and negative 6.
Yeah, it's 3, -6.
Oh yeah, I forgot.
Because it's the opposite of what you see here and the opposite of what you see there. So the starting point is 3, -6. Now, unfortunately, to make this graph fit, Jesse, on the page, I had to cut off parts of it. So my starting point is actually way down here. That's my starting point, 3, -6. And then we use the slope of -2 to go down 2 over 1, or you can go up 2 to the left 1. Either way, it doesn't matter. For those of you who haven't caught on to that, -2 over 1 is the same thing as 2 over -1. They are the same thing. So you can do the rise negative or you can do the run negative. It doesn't matter. You will get the same result. So the whole point of point-slope form is knowing how to pull the starting point out. So no offense to Amari, I really appreciate her trying, but she's going to have to do a better job because it's only been a few days since we learned it, and you're going to have quizzes and tests, and you not only have to know it, you have to have it mastered. So we have some work to do to achieve that mastery. Okay? We're going to get back to that. Don't worry, there's going to be lots of review. All right, we're going to pause. So, today, of course, you titled your lesson 4-9. Make sure you wrote part 1. This time, the two lessons, part 1 and part 2, are going to be graded separately. So part 1, we're going to be discussing and building the idea of parallel perpendicular lines, and we're already partway there. We used a little bit of creativity during the warm-up to kind of discover the meaning of parallel lines. We're going to continue that idea. I've given you a notes companion that has 2 graphs. If you would find the 2 graphs, one of them is this one. And also keep in mind throughout today that my projector does not project color correctly at all. So on my computer screen, the top line is red and the bottom one is green. And clearly up here, that's not the case. It's going to actually happen a bunch of times today. We're just going to have to deal with it the best that we can. There's nothing I can do about the technology not working right. So now here's what I would like you to do. I would like you to take this first graph and I would like you to find the slope. Find the slope, please. It should take, of both lines. Find the slope of both lines. It should take you 30 seconds to a minute. Go. All right, so you should have the slope of both of them. What is the slope of the top line, the uppermost line? What's the slope? So we'll keep the equity bars going since everyone's doing this. So what is the slope of the top line? Student number 10. I'm sorry? Well, look at the direction the line is going. Is that positive slope, negative slope, zero slope, or undefined? Positive. So now you said the slope was, okay, so does that make sense? So now you need to go back and fix it. Could someone fix his mistake for him? Adriana?
It's 1/2.
Yeah, it's positive 1/2, absolutely. And so what about this second line, the bottom one? What's the slope of that one? The slope of that one? Number 1.
It's also 1/2.
It's also 1/2. And we can show that by doing rise over run from any 2 points, like here and here. Rise +1, run +2, +1, +2, that translates to this. And we get the same thing here. +1, +2. So this is something just reinforcing what we just figured out during the warm-up. And this goes back to what Garion said. If 2 lines have the same slope, then they are parallel. The converse of that is true. You'll learn what converse means next year. Converse means you flip it around. If 2 lines are parallel, they have the same slope. If 2 lines have the same slope, then they are parallel. It works both ways. Does anyone have any comments, questions about the idea of parallel lines and their slopes? Yes, Amir.
Mine for this one, the 5 line, I got 1/4, but it goes up 1, but then it has 1, 2, 3, 4 to get to the next point, like process the grade on that.
Well, if maybe your teammates can point out to you the flaw in your thinking, because it doesn't. Your graph is the same as everybody else's. If not, then I'll come and take a look at it, okay? So, now let's look at the second graph. And I would like you to take a minute, and I would like you to find the slopes of both of these lines. Find the slopes of both of these lines. You got 1 minute. Go. Okay, so you should have the slopes of both of them. One of mine is blue and the other one is orangish, greenish, yellowish, muddy colored. So let's start with the blue one. What is the slope of the blue line? Slope of the blue line. Slope of the blue line, student number 3. 2/3. What is the slope of the other line? What is the slope of the other line? Student number 9. The slope of the other line, 3/-2. And you also learned that negative can go top or bottom. It doesn't really matter that the negative is there. It could go here, it could go there. Doesn't matter. So those are the slopes. If you made a mistake while figuring it out, use your colored pen to fill in the correct slope. But now I want you to look at them together and see what you observe. You have 1 minute as a team to make any observations and share them with regard to the numbers that you are looking at. Any observations you see? Talk to them. Talk to them.
If you wrote down the rule for perfect, you would see. You didn't write it down. Take it.
Make sure you're prepared to say something. Doesn't necessarily have to be what I was looking for. It could be any observation at all. All right. What did you observe? Team C and Team E. Team C, what did you observe? Tristan?
I observed that the green line is negative.
We observed that. Continue.
We observed that the green line is a negative and the blue line is a positive.
Very good. Stop right there. Team E. Is that Team E? Okay, go ahead.
Okay, well, we saw that one line is negative, one line is positive, and they're perpendicular.
Okay, how do you know they're perpendicular?
Because they're opposite reciprocals. Because you have to, it's flip the sign and flip the number.
Ah, because I already gave you a little head start on the notes. You already caught that. So that was a good catch. But yeah, that was really what we were trying to focus on. I'm really glad that you pointed out one line was negative and one was positive. That's something that should be in your head. But I was asking you really to focus on these numbers and observe the numbers. And so what we discover is that when you have perpendicular lines, which means that this is a 90-degree angle, then the slopes will be opposite reciprocals of each other. So here are the words that describe everything that we have discovered so far. Parallel lines have the same slope. Perpendicular lines have slopes that are opposite reciprocals of each other. And opposite reciprocal, I'm going to say, means flip the sign, flip the number. I'm saying that so that hopefully it's kind of rhythmic for you and it will stick in your mind. Flip the sign, flip the number is just kind of a silly Dr. Seuss-y way of saying opposite reciprocal. You need to know the phrase opposite reciprocal. I know it's a big boy word. You're supposed to know it. So, we observed that here in this graph at the bottom. These are opposite reciprocals. Let's look at some other ones. So I would like you to make a simple T table, which just means make a T, don't make it fancy. And let's find some opposite reciprocals. So we'll do the first two step by step, and then the other ones you guys will tell me what they are. So, if one line has a slope of -5, I want to know what will the perpendicular line's slope be. So the phrase is flip the sign, flip the number. So let's start with flip the sign. So what's the sign of my new slope going to be? You got a 50-50 shot, so don't blow it. Okay, Chopin? It's going to be positive. Flip the sign means opposite. Now flip the number. So what's the number part of my slope going to be? Cheyenne? 1/5. Very good. Cheyenne, where did the 1 come from? Very good. That was a beautiful explanation. So flip the sign, flip the number. Negative becomes positive, and the bottom goes to the top, top goes to the bottom. Any questions about that? Good. So let's continue and check out what happens if I have 4/7. Flip the sign, flip the number. What's the sign going to be of my perpendicular slope? Yudesh? It's going to be negative. What is the number going to be for my perpendicular slope? Alex? 7/4, so we get -7/4. Good. Now, you do that one. Should take you 5 seconds. What do you get? Jesse? Flip the sign, flip the number. +8. Very good. Flip the sign, flip the number. And what about that one? Do it yourself. It should take you 5 seconds. What do you get? Just 2 people were able to do it? Okay, I can deal with that. Laura? Very good. Flip the sign, flip the number. So now we know how to find an opposite reciprocal. That is not today's lesson at all. In fact, we haven't even started really. But that's a skill you need to be able to do what we're going to do today. Anyone have any questions so far? Any questions so far? Okay. For this? Okay, well, I'm turning the page in 5 seconds. 5, 4, 3, 2, I lied. Okay, so example 1, part A, we're going to start with parallel lines, then we're going to throw in some geometry, then we're going to go to perpendicular lines. We've got a lot going on. So, the instructions. Identify which lines are parallel. Yes, you need to write down all of the equations. Doesn't need to be perfect, just write quickly. So, you have all 4 of these down, written down. Now we want to know which ones are parallel to each other. So I'm going to ask Garion to make his statement one more time to remind us. And hopefully you can do it almost the same as he did before, if not exactly.
So, if 2 lines have the same slope, then they are parallel.
2 lines have the same slope, then they are parallel. So what should we be looking for? What should we be looking for right about now? Amani? You said that so perfectly. In another group this morning, it took like 10 minutes to get to 2 words. Same slope. So we just have to look. So what's the slope of this first equation? Can someone tell us what the slope is? Catalina? 5/3. Oops, excuse me, I apologize. 5/3. What is the slope of this second equation right here? Marcus? Slope is a number, it is not a variable. It is 1. There is a hidden little 1 right there. What is the slope of this third equation? Third equation, Amari? 5/3. What is the slope of this fourth equation over here, Yasmin? It is 1. So I'm going to write that in just so we can see it. So there is a 1 right there, and there's a 1 right there. So now someone make a statement. Tell me which ones are parallel. We can call it equation 1, equation 2, equation 3, equation 4. Which ones are parallel? Chanel? Good. Equation 1 and equation 3 are parallel. Can someone make another statement for us? Marcus?
Equation 2 and equation 4 are parallel.
Very good. Equation 2, equation 4 are parallel. Does anyone have any questions? Any questions on what we did? Now I have a follow-up question. What form are all these equations in? They are all in the same form. What form is it? What form is it? Alex? They are all in slope-intercept form. And so because of that, we were instantly able to see the slope. Nobody seemed to struggle finding the slope. Any questions about that? Now, I do have a graph of all of this. You don't need it. I just wanted to show you. And it didn't come out exactly the way I wanted because of the coloring getting messed up. But these 2 lines here are parallel, and these 2 lines here are parallel. These 2 are the ones that have those slope of 1, And these two are the slope, one that had the slope of 5 over 3. So you can see it visually, but you don't need the graph because we can see it right here. Any questions about that? Good. This is Algebra 1 Honors, so let's take it to the real work. So now identify which of these lines are parallel. So, I'm going to ask the same question because Gary has told us several times already that if lines have the same slope, then they are parallel, so we need to focus on finding the same slope, like Amani said. So let's look at equation number 1. What's the slope? What's the slope of equation number 1? Alex? 2. Excuse me, right there. What's the slope of equation number 2? Catalina? 8 over, I don't see that at all. Where is that? Oh. Oh, okay, I didn't realize. All right, so let's come back to that for a second. I'm sorry. So let's go to equation number 3. What's the slope of equation number 3? Kaylee? Negative 2 over 3. What's the slope of equation number 4? Yadesh? I'm sorry? 3. Very good. Okay, so we can see the slopes of 3 of them, but we can't see the slope of the second one. So Catalina, you said we had to do something?
Yeah, but I said the wrong slope.
Okay. What is the slope then?
Negative 2 over 3.
Okay, and how did you get that?
You will subtract 2x from both sides, and you divide everything by 1. 3 by 3. I mean 3 by 3.
Okay, so overall you are doing what to the equation? You are, wow, you said that so beautifully. Transforming it into this form so that we can see this. In this form, what's that form called? Chanel? That's standard. So we can't see the slope very easily. But if we convert it like she just said, and it was so effortless for her to say, oh yeah, you just subtract 2x from both sides, and then you divide everything by 3, and remember that means you divide individually by 3, and now all of a sudden you've got slope-intercept form. Now you can see the slope. So now we can answer the question, which lines are parallel? So I need some volunteers to make some statements for me. Which lines are parallel? Which lines are parallel? Paige, give me one statement. Line 2, which is this one, and line 3 are parallel. Yep, I'll buy that. Give me another statement. Tristan? Beautiful statement. There are no other parallel lines. That is it. Any questions on how we went about this? So the difference in part B was that one of the equations was not in a convenient form. So we transformed it. I love how she said that. Transformed it into slope-intercept form so we could see the slope. Any questions about that? Okay. Checkpoint number 1. I would like you to tell me which of these lines are parallel. Which lines are parallel? You got 3 minutes. got 30 seconds to compare with your teammates. Come to some sort of agreement on what you think are parallel. 30 seconds. Quick.
I just draw lines when I'm finished.
That's good.
What did you say? Sure. Okay, so let's see what we got. Team D and Team B. Team D, what do you guys conclude? 1 and 2 are, and then 3 and 4 are? Okay, Team B, what do you think? Kayla, you go ahead and speak.
Equation A and B are parallel. Equation C and D are parallel.
I'm assuming you're going left to right, A, B, C, D?
Yes.
Okay. So, we have two teams that think these two are parallel and that these two are parallel. Anyone have any disagreement? We have disagreement there, disagreement here. Chanel and then Paige and Kaylee. Chanel. Okay. Do you guys think the third one and the fourth one are parallel? Okay, so we can all agree that these two are parallel? Okay, but there seems to be a dispute about the first two. You don't think the first two? What did you guys not think the first two? Okay, so why is the first two not?
Because if you put them into the graph, they would both be on the same line. Yes.
Oh. When we convert this into slope-intercept form, what does it come out to, Isabella? I saw it on your paper. That's not parallel, that's the same line. So it was a little bit tricky, and it's okay if you didn't catch that. Don't listen to me, not your classmate, listen to me now. It's okay if you didn't catch it. But now moving forward, remember this is Algebra 1 Honors, you are supposed to be able to distinguish details. And unfortunately, even though they have the same slope, they also have the same y-intercept, which means they're not parallel, it's actually the same exact line. Any questions about that? Good, let's continue developing this idea, but now apply it to an actual geometric application that you're going to start seeing next year all the time. So today is just an exposure to it. So, show that JKLM is a parallelogram. Show that JKLM is a parallelogram. So for those of you who don't know what a parallelogram is, a parallelogram has two separate sets of parallel sides. A parallelogram means that this is parallel to this, and this is parallel to this. So if it's a parallelogram, in this case, the top and the bottom will be parallel, and the left and the right will be parallel. So we need to check to see if their slopes match up. So let's start, let me get rid of these for a moment because we don't know if that's true yet. Let's start with this line. By the way, if you look at, I gave you this sheet. So take your slip, it should be now in your notes. And so we want to know the slope of this line right here. How can we get the slope of that line? I apologize, I asked it incorrectly. Put your hands down. Give me a thumbs up if you know how to find the slope of what I now drew as a blue line. Okay, some of you don't know how to do it, but a lot of you do. Good, put your thumbs down. Yasmin, how can we do it? Rise over run. What's the other way to do it? What's the other way, Jesse? Which one do you think is easier, Yasmin? Yeah, I would say rise over run is much easier. So, if we do rise over run, we go from here, rise, run, and now count. Rise, 1, 2, 3, 4, up. So that's positive 4, and run 1. So the slope of this side is 4 over 1. Now let's check the opposite side and see if that happens again. Rise, rise over run. And again, we rise 4 plus 4, run 1, we get 4 over 1. So, this is what we can say. This line has a name. You name it using its endpoints, the J and the M, and you put a bar over it. That means segment JM okay? And then we have segment KL. Sorry, excuse me. And segment KL have M equals 4 over 1. So we have shown that the opposite sides, left and right, are parallel, but now we need to show the top and the bottom. What's the slope of the bottom? Everyone should instantly know. I should see hands frantically waving in the air and people going like this. What's the slope of the bottom? What's the slope, Amani? It's 0. That's the bunny slope. That's super gentle. What's the slope of the top, Amani? So they are they're the same. So we can say that JK and ML have a slope of 0. And so now we have proven that yes, this is a parallelogram. Yes, it is a parallelogram. Does anyone have any questions on how we went about doing this? Tristan?
Well, no, I want to do it like the JM, like just put the J like right across the line.
I don't understand your question.
Like how you do a regular J, you just carry the.
You're talking about because a capital J has a line on top like that?
Yeah,
But you don't have to do that. I mean, that's no big deal. Minor detail. Okay, checkpoint number 2. Let's see how you do with this one. Show that ABCD is a parallelogram. And I have given it to you. It's on your slip, so you can actually write right on it. You don't have to redraw it or anything. Because you don't have to redraw it, I'm giving you 2 minutes to figure it out. If there's time left over and you're done, see if your teammates are done and see if you have the same method, same results, etc., etc. Okay? So give me a thumbs up if you were able to prove that it's a parallelogram. Thumbs up if you were able to prove it. Okay, some people weren't able to prove it. Okay, but some people were. Okay? Michael, what is the slope of segment AD? So, you should have gotten slope of 5 over 3, 5 over 3, and then a slope, as Amani had taught us earlier, slope of 0, and yes, this is a parallelogram. Does anyone have any questions on how we apply the idea of parallel lines to a geometric application? Yes?
Well, the top and the bottom lines are not be 0.
Yes. There will be a time where it won't be 0, so you would have to find the slope of the top, find the slope of the bottom, and compare them. Okay? Good question. Any other questions? Yeah. Well, this year it's forgivable. Next year it will not be forgivable. Okay? In geometry, you have to know when to put a line and when not. You don't worry, your geometry teacher will teach you. Okay? All right, so now we've taken care of parallel. Now let's talk about perpendicular. We already built the foundation, and it's almost the same statement that Gary made, except two lines are perpendicular if their slopes are opposite reciprocals, and we introduced this simple way of trying to remember what it means for an opposite reciprocal. Flip the sign, flip the number. Any questions about that before we start applying it? All right, so let's go ahead and apply it to this. Identify which lines are perpendicular. So I start out with an easy one, and then there's a couple things in here that I'm going to work in as well. So make sure you write down all 4 equations. And we're trying to identify perpendicular lines. And perpendicular lines form a 90-degree angle. So that's what we're trying to figure out. We could draw the graph and take out a protractor and measure it. I got a whole box of protractors right here. We could draw the graph of all of them and just check with a protractor. But because of what we've discovered, we don't have to. We need to look at slope. Now, I understand that the first 2 lines are a little bit unusual, so let's forget about them for a second, and let's look at these 2 here. So, you should be able to see the slope. What's the slope of the 3rd line, y equals 3x? What is the slope of that, Tristan? Good. What is the slope of the 4th line over here? Amari? Negative 1/3. So now the question is, not are they the same, now the question is, are they opposite reciprocals of each other? Give me a thumbs up if you think they are. Okay, some people think they are. Good, put your thumbs down. Because of that simple fact that they are opposite reciprocals, these 2 lines are perpendicular. Anyone have any questions about that? So we're still looking in the same place, but now we're looking for something different. Looking in the same place, but looking for something different. Now let's look at these 2. And this is something that you've seen already, and you're going to see more today, and you're going to see continually for the rest of the year. Does anyone know, let's look at this first one. Does anyone know what this looks like when you graph it? Amir? Vertical line. Tristan, what were you going to say? Okay. Well, that is what most people say. Unfortunately, it's a counterintuitive idea, and it's actually a horizontal line. This is actually a horizontal line passing through 3 on the y-axis. In fact, any equation that is in this same form, y equals a number, will always be a horizontal line. So it could be y equals -8, and that's a horizontal line passing through -8. It could be y equals 1/2, and that's a horizontal line passing through 1/2. Doesn't matter. If it's y equals, it's a horizontal line. So now, my thoughtful students, what do you think this looks like when we graph it? Yudesh? It's going to be a vertical line. X equals -2 is a vertical line, up and down, passing through -2. Any equation that starts with x equals and ends with just a number is going to be a vertical line. It could be x equals 3, it could be x equals 19, it doesn't matter. It's going to be a vertical line. Okay? So let me back up. If one of them is vertical and one of them is horizontal, what does it mean about the two of them together? If one of them is horizontal and one of them is vertical, what does it mean for them together? Jesse? They are perpendicular, absolutely. Look at any horizontal line in my room and find a vertical line that's going with it. My bulletin boards, my whiteboard, my Promethean board, the column and the floor. These are all vertical lines meeting a horizontal line, and they all meet at 90 degrees. So these will always be perpendicular. Does anyone have any questions about that? Good, we're doing quite well. Let's wrap it up with one more. Determine which lines, if any, are parallel or perpendicular. So we're going to put it all together. Which lines, if any, are parallel or perpendicular? So we know three forms of an equation. We know standard form, slope-intercept form, point-slope form. Which one do we really love to have to make this easy? Which one do we love to have so that we can just quickly find slope, Cheyenne? Slope-intercept form makes it super easy. Cheyenne, are any of the lines in this question already in slope-intercept form? Which one? I'm sorry? Yeah, line B is already in slope-intercept form. So it has a slope of -3. But we don't know the slopes of the other ones. What form is line A in? What form is that, Catalina? Laurel, what about line C? What form is that? Standard. So we have to do what Catalina taught us earlier. We have to convert them. Or you guys are you're advanced, right?
Yeah.
Okay, so then all my advanced students, you pay attention now. All my students who don't think you're advanced, you convert line A and C. All my advanced students are with me. My non-advanced students, you do your own way. There's actually, this is standard form. And you have to know this, by the way. This is capital A, capital B, capital C. There's a simple way to get slope when it's in standard form. It will be the opposite of capital A over B. And it's written like this. The opposite of A over B will be the slope when it's in standard form. This is only for my advanced students. So you can easily find the slope of line A by just doing the opposite of A. So A is -1. The opposite of it will be +1. Over B, which is 3. And you could do the same thing for line C. Because it's in standard form, you can do the opposite of A. A is 2, so the opposite of it will be -2. Over B, which is -6. Now put that in simplest form, and what does that come out to in simplest form? Of course, it comes out to 1/3. Or use the method of converting the equation or transforming it into slope-intercept form. Either way, you'll get the slopes. So now we have the three slopes of the three lines. 1/3, -3, and 1/3. And we are asked which lines are parallel or perpendicular. So now we need to make statements. So I need some help. Can someone make one statement from our information? Make one statement. Chanel?
Make a statement.
We are asked which lines are parallel or perpendicular. So I want you to tell me in words which ones are parallel or but just tell me one thing. Line A and which one? B and B are perpendicular, you think? Give me a thumbs up if you agree with her statement. 1/3 and -3 opposite reciprocal? Absolutely, she is correct. Line A and B are perpendicular. Are there any other statements that we can make? Kaylee?
Line A and C are parallel.
Line A and C are parallel. All right, before I circle that one, let's check. Give me a thumbs up if you agree with her statement. I got double thumbs up from some people. That must be a good statement. Absolutely, that is correct. Is that it? Anyone have any other observations? Paige.
Lines B and C are perpendicular.
Line B and C are perpendicular. I'm going to write over here. Line B and C are perpendicular. Give me a thumbs up if you agree with that. Yeah, I agree with that. Yeah, we had 3 statements we were able to make. So, we have figured out which ones are parallel and which ones are perpendicular.
But that method that you just taught us about like m equals -a over b, wouldn't you possibly get it wrong because like it happened with the
Yes.
template?
Yeah, I'm really glad you pointed that out. It actually happened earlier today. That if we had used that method here, we wouldn't have realized that it was the same line. Very keen observation. Very, very impressive. Because the opposite of A over B here is 3/4, and then we would have said, oh yeah, those two are parallel. But they're not really because of the +8. So, very good observation. So sometimes you might need to check a little bit. So, great observation. All right, any comments or questions? All right, we did have a final checkpoint, but I'm going to skip it. Your homework. Make sure you copy this down accurately and copy down everything. On page 247, you're doing numbers 1 through 8, except number 3 has 5 separate lines. It counts as 5 separate questions. On page 248, you're doing numbers 1 through 5. In the old workbook, this is critical. You are doing numbers 16 through 21. This is a review. Do it on graph paper. Do not tear out the pages from the old workbook, because I reused the pages later on. So do not tear out those pages. You will have a test on chapter 4 after Thanksgiving. But, and I do expect the typing practice to continue, especially during Thanksgiving, but you're going to have something special on Monday. One second, Paige. You're going to have something special, an assessment quickly on Monday during checkpoint. When you come in, you're going to have a 1-minute quiz. You're going to have a formulas quiz. You need to know your formulas, and there are 5 of them. 5 formulas for Monday. The 5 formulas, 4 of them are right here, and the last one you learned last time. I don't have a sign for it because it's so easy. Y equals kx, and that is a direct variation. You will have 5 formulas you have to write down. You will have 1 minute to do it. 1 minute, 5 formulas, that's 20 seconds per formula. If you do not have them memorized incredibly well, you will never finish in 1 minute.